Okay, class exercises 3.5, problem number 1. This whole section deals with transformations. If you add outside of the function, so to speak, past the f of x, it's going to be shifted up. If you subtract, it's going to go down, and that affects the range. If the change is inside, right next to the x, it's backwards. If it says minus c, it's to the right. If it says plus c, it's to the left. So that affects domain. And then the reflections. If the negative is out in the very front, it reflects in the x. If the negative is right next to the x, it reflects in the y. And of course, those are the impact. If you have a number in front of the function, that is a vertical stretch or compression. If it's greater than 1, we say it's a stretch. If it's between 0 and 1, we say it is a compression, and that you would multiply the values, the y values, by a is what you would do. If you have a term like this b right here, right next to the x, that's a horizontal compression or stretch. If b is greater than 1, it is a compression. If 0 is less than b, which is less than 1, if it's between 0 and 1, then it's a stretch. It kind of moves them out there. The order that you should do these transformations in is the horizontal transformations, then the stretching or shrinking. The third thing is reflecting. The fourth is the vertical transformation. If you don't do them in order, a lot of times it's wrong. Sometimes it might not matter, but most times it does matter if you've got them all. And number 1 says to graph the following function using these particular techniques and then find the domain and range. Well, we want to analyze the transformations first. This is your function. The first transformation is your horizontal, then go through. The beginning, the parent graph here is the square root of x. This is the way it looks. Its domain and range are both 0 to infinity. Starts and keeps going for x and for y. That's what that means. Now, the horizontal is first, so we're going to take that plus 3 that's in here, and that moves it to the left 3 units. So the point that is at 0, 0 is now going to go to negative 3, 0. That's what happened when you just did this part. Okay, after you do the horizontal, the next is the stretching and shrinking. The 2 in front of the radical is going to do something with that. So you use the rule here, and basically the y values are multiplied by 2. So if you took this particular point that you started with, the negative 3, 0, it really doesn't look like it changes. But if you look at the whole thing, you'll see that it's kind of stretched up more, crossing right here at about between 1 and 2, and then this one crosses between 3 and 4. So it has had a vertical stretch there with that too. Then, if you go back up and look at your original, you still got one more thing to do, but we've stretched, we've shrinked, done shrinking, stretching. There is no reflecting, but there is the vertical transformation, and the plus 6 is going to be the vertical transformation. So you're going to take this point and you're going to shift it up 6 units. So it should become negative 3, 6. Take the graph, we shifted it up 6 units. So where we started with 0, 0 is now negative 3, 6. It's kind of like an anchor point, and that is the actual function there. So we've moved it up. And the 6 is like the b values up here. Actually, the 6 is like a d value, is really what it is. because you're moving it up. So it would be sort of like a D from the rules that are given up there. So you move it up 6. Now you can finish with the Math Excel problem. The correct graph here, you want to find the one, really the only one that has kind of like the beginning point in the anywhere near the right location is D, the -3, 6 point. Your domain would be from -3 to infinity. The range is from 6 to infinity. The range is 6 to infinity. To infinity, domain and range. Okay, doesn't ask you anything else. You started out with a domain of 0 to infinity. Your range was 6 to infinity. So you had a change in the domain and in the range.